Hi, this is PD at BurgZerg Arcade at BurgZergArcade.com, and this is part 7, I believe, of our little tutorial series for our community challenge number 1, which was a breakout game. I was just about to start up doing my tutorial, and all these blocks were kind of bothering me, and I know there's going to be a lot more that I want to add, and I'm pretty anal about having a lot of organization in my scenes. So what I'm actually going to do is actually come in and create a new game object, which is just going to be an empty, and I'm just going to call this row 1, and I'll just duplicate it, and the other one's going to be called row 2, and all I'm going to do is just come into my scene view, hold down my command key, I believe it would be control on the Windows machine. Let me just get a different angle here. Anyway, what I want to do is go ahead and actually select all these blocks on the bottom row. Let me actually switch to a different element so I can actually, instead of constantly clicking on the, that's not going to work either. Instead of constantly clicking on the little arrow. What if we zoom in a bit? Anyway, I want to select all these blocks in this first row and just put them in row 1. Parent them there, and that means all the rest are in row 2, and I'm just going to put them in there, and it's just a little bit cleaner and it'd be a little easier to kind of get to. It might even be nice to kind of number them or something like that, but that's good enough for now. It's a little bit of organization, and it also makes it a little bit easier to make a new row, so I can just go in and duplicate, make a row 3. We'll just move this up a bit. I think it was 1.5 we're removing them. Maybe not quite. Maybe it was 1.2, 1.3. I'd have to take a look. Anyway, yeah, then I can also go in and change their colors, make them blue. I'm just going to do the first one. Well, it's not technically the first one, but the first one in the little list. And there we go. But anyway, that wasn't what this tutorial was about. It was just kind of one of those things when I was looking at the scene kind of bothered me. So let's go back into our ball script. And the first thing I want to do is actually start decreasing lives when the player misses the ball. Now we can simply do this in our update function just by checking the position. And if that position is lower than what the player is in the game by a certain amount, so like when the ball gets below the player, it's obvious he's missed the ball, and we want to subtract a life from it. So I'm actually just going to grab the ball here, and I'm going to start moving it down on the Y just to kind of find out exactly where I want to start subtracting a life. And I'm going to say probably 4.5. It looks good. Yep, if it gets there, he's definitely missed it. So negative 4.5. So I'm just going to zero that back out. I'm going to come back into the script, and we'll just do a check here. Make sure you're in the ball, and we'll just check to see if we were using T for the transform. We actually don't have the transform here. Well, fine. We'll just go ahead and add it. I'm just trying to think if I'm actually going to use the transform anywhere else. I don't believe so, but I am using this every frame, so I might as well cache it. And I'll make it private. And just like the rest, I'm just going to do underscore T. And of course, in the awake function, we assign negative T to be equal to our transform. There we go. So now when we come down here, we should be able to go dot position, and we're going to check on the Y. And we're going to see if it's less than negative 4.5. Did I cut and paste it? I did not. 4.5. That means we've actually gone past the player, and they need to lose a life, and we want to reset the ball as well. So I'm actually going to create a new function, and I'm going to come down here for it. Right after all the Unity functions. I will make this private for now, as I don't see a need to make it public just yet. And I'm just going to say reset ball, maybe missed ball. It does not accept any variables. I'm going to leave it blank for now, but I am going to come up here and actually call this function. And after that function is called, I'm going to come down here and do what I need to do. So the first thing I want to do is go to lives dot current lives and decrement. So we'll get rid of one. Then we're going to check. Well, we can actually do both of this in the same step. So we have the lives, decreasing the current lives by 1, and the next line could be an if statement to check to see if the lives are less than 0. But you can actually do both of these in the exact same line of code. So if lives minus minus is less than 1, we're going to do something. Basically, we're going to call the game over. So I'm just going to put a comment here. Well, usually I have some sort of master script. Maybe for instance, this game I would make a script called Breakout, and it would contain all of the kind of master functions for the game that pertain to the game itself and not the actual game objects attached to. But I'm trying to stay away from that in this tutorial series. So I'm actually going to put all that code here in the ball itself. So if we miss the ball, I'm going to need another function. Well, let's call it game over. And we'll play with that a little bit later. So anyway, if we have less than 1 life, that means we have no lives left, and well, I want the game to end. So I'm just going to call game over. But if we do decrease the lives and we're still above 1, or at least not less than 1, I want to do something else. And that's basically just going to be reset the ball, which again, I will make a new function for. And I'll just call that function. Okay, so what exactly we're going to do to reset the ball, we'll do that one first. All we're really going to do is just put the ball in the starting position again. And we don't actually have a function to do that, or anywhere at the beginning where we're actually positioning the ball. So I'm actually going to put that in the reset function down there. And I'm also going to call that up here, reset ball. I'm going to add this line of code down there. And before that line of code, I actually want to put the position of the ball. So we're going to say underscore t dot position is equal to new vector 3. And just like all the other vector 3s, we need an x, a y, and a z. And I'm going to come up here and just take a look to see if we have actually anything saved up there. We do not. But we do know that we are saving the z index, or the position on the z axis, which is 0, but we are saving that in another script, which is the player script. And since I am moving all of those kind of or I guess kind of universal variables and functions into one script, I really should move that over here. And if you feel like it, go ahead, but we do know where it is, and the game is not that big or complex, so it's not like you're really going to lose it. But let's go ahead and call that player dot, I called it z position. There we go. And of course I spelled it wrong. And now we're going to need the y position for the starting y position and also the starting x position. Now you can kind of put anything you want in the x position. We'll probably actually fool around with this a little bit as we go along, because I kind of want it to start at a random position in between these two walls. But for now, I'm just going to make it start in the center. And on the y, I'm just always going to have it start at 0 on the y. So I'm just going to put a 0 here as well. So there we go. There we go. We're going to position it and set its random, or set its relative velocity, or relative force, I should say. And on game over, I'm just going to throw a quick debug log in here. that just simply says, game over. Let's just go ahead and run it. And I'm going to miss the ball. And we see that the ball resets and the lives are going down. And not exactly what we want, but we can actually, well, we don't want to destroy the ball just yet. But as you see, we do get the game over, and we do want to take care of this. I'm going to leave that for a little bit here. There's a few other things I do want to take care of. For instance, getting the ball to actually bounce in a different direction would be kind of nice instead of always being straight up and down. So let's take care of that now. So I'm going to come back up to the update itself. Let me see. We're going to come up, right here in the update. Actually, there's probably a bit easier way to doing this, or at least something a little more creative. I'm actually going to come down to where I'm resetting the ball, and I'm going to actually change its position. And if we go back and look at the game, we have our ball starting at the 0 right here all the time on the X. I actually want it to be anywhere from say a little bit out from this wall to anywhere out in this wall. So in order to get that, we can just use the random range function in Unity. And there's also one built into .NET. But we're just going to use the one that just automatically pops up, which I believe is the one that actually comes with Unity. I'd have to check to make sure, but I'm pretty sure it is. If you wanted to really make sure, you could prefix it with the library that you want to use. But we'll notice here that it takes two integers, a minimum and a maximum. And if we push up and down, we'll notice that it actually has two different sets of parameters it can take. One is a float and one is an int. I'm going to be using the float one. But what I want to do is take the x, I believe it was in our player script, the x boundary. Yes, right here. Our x boundary that we actually have saved for our actually, we're going to have to find another way to do this because we have it set as a public. And if we go ahead and take a look in here for our player, we're setting him in here. So we're probably going to have to switch this over to being static to do this. So I'm going to come in and say x boundary static float, and instead of equaling 0, I'm going to attempt to paste it in. Let's close this down. And now we should be able to actually access this in here without getting a reference. Worst case scenario, we just got a reference here and pulled in the values, and it's not too bad. But for now, I'm just going to make it static. So now I'm going to call player.x boundary, and I want the negative version. So I'm going to say negative, and I'm going to put these in parentheses just to, well, no, I'm not. But what I am going to do is add, let's add 2 to it. This is going to be my minimum. So it's going to be 2 in from the wall. And let's take, for the maximum, we'll do the exact same thing, except we're going to use player.x boundary, and we're going to subtract 2. So let me just take a look here. Yeah, looks like everything's okay. So now it's going to be anywhere from 2 in from this wall to 2 in from this wall. And to start off with, I'm going to make it a little easier for our player. I'm going to make it actually look at the player before it actually launches. And we can just do that by calling its transform, look at. And if we look at the code here, what it takes is a vector 3, and it's looking for a world position. And we want to get the world position of our actual player. So what I'm going to do is just go game object dot find game object with tag. I remember at the beginning we said we wanted to tag our player with player, just in case we ever needed to find it. And since I don't really need to store this variable anywhere and keep a reference to it, I'm actually just going to call its transform right away, and its position, which will return a vector 3, and I'll just use it that way. And then I'll add my relative force. Now this is going to change a few things. It rotates the the ball, and then we're going to go ahead and make the ball move. So let me just see here. Now, since we actually have the ball looking at the player and we want the ball to actually move forward towards the player, we don't want it to move on the y-axis anymore. If we want something to move forward, we want it to be on the z. So I'm going to save that off. There's a couple little things I'm going to do actually in game. If we go ahead and select the ball, I'm going to come down to the constraints. I'm going to turn off the rotations, but I'm still going to freeze the position. And if I come over to the scene, I want to make sure that I'm on local. And if I start the game up and pause it now, we'll see that if it was on global, you wouldn't know what way the ball was facing. But if we go on local, we can now see where, well, the ball is facing. And I'm actually going to come into the game, and well, too late, it's over. That's fine. But anyway, you got the idea. The ball is actually spinning around now. And actually, let's play a bit. Actually, there's one more behavior I want to fix. If we come back into the ball material, I'm going to switch the friction combined to minimum. It's going to make the ball move a little bit faster, but give a more realistic bounce. And we'll just start this off. And there's probably one more thing I'm going to want to add to the ball itself, and that's a bit of randomness to the actual bouncing. And there we go. Basically, I want to take it so that when the ball hits my paddle, or basically any object in the game, where it hits based off the center of the object, it will change the angle of deflection a bit. Just so you don't get in the scenario where you'll have a ball bouncing from one wall to the other on a perfect X, and it can happen. You'll notice if you're actually watching the inspector, the X position will keep changing from side to side, but the Y position is always the same. We will want to stop that. But let's see, next thing I actually really need to get done. Here we go. I managed to get it here. We need a little space bar for our jump. Okay, the Y position is changing a bit. But you get the idea. If we had some sort of not a multiplier, but some sort of way to adjust maybe a minimum angle that it would bounce at. Now, you don't want to be too drastic because you do want the ball to be fairly predictable, but you do want to stop those instances where it doesn't bounce too much. So I don't want to get too technical in it because this is meant for beginners. So let's go ahead and head back into our code. I think that's everything there. We still need to do the game over. For game over, I'm actually just going to take the ball. Maybe it's velocity. I basically would call some sort of game over scene. And we've already done other tutorials on how to change scenes. And that's really not what the focus of this one was about. You're still going to need another function here to actually go on to the next level. And that I do want to cover. But as far as the actual game over goes, I'm just actually going to stop the ball. So what I'm going to do is take the rigid body dot velocity, and I'm just going to equal it to 0. Actually, it takes a vector 3. And there we go. Let's just quickly go test that just to make sure that's working. So 1, 2, 3. So there we go. I guess I should move it and hide it as well. So we switch the velocity to 0. Let's move it. Position is equal to vector 3 dot 0 as well. So I'll just throw it back in the center of the screen. And let's actually, I don't want to turn the whole game object off because it actually turns this script off as well. But I do actually want to turn off its rendering, so I don't want to actually look at the thing. And I'm actually going to do that first. So we'll just say underscore t dot renderer dot, and I believe it's enabled, right? And then we're just going to set this to equal to false. There we go. So turn it off so you can't see it. Change the velocity to 0 and move the position to the origin. So we'll just start it off. I don't want to hit it. There we go. Now we don't really want the -1 either. So we can actually come up here and we'll say if the lives are less than 2, whoops, wrong spot. It does not want to let me edit this. There we go. It's expecting an else, and it's because I accidentally deleted a few semicolons. And we'll let it go one more time. 3, 2, 1, 0. There we go. That's the behavior I want. And of course, you know, you can put other things in that function as well. Maybe a big game over pops up, whatever you'd like. But we want a way to be able to win the level. So in order to do that, I'm going to go ahead and take my blocks. And I did not tag them ahead of time, but luckily I did make a prefab. And I'm just going to check the blocks here. I thought I made a block prefab. Way down here. I'm looking in the layouts. Alright, so I do not have a tag. I'm going to go ahead and create one, and I'm just simply going to call this tag, I'm sorry, that's under layers. I want to go under tags. I'm simply going to call this block. And actually, well, let's stick with the capitalization. So again, select your block, go up here, take your tag. Since the rest are capitalized, I kept mine capitalized. Now if we select any of the ones up here, we'll notice all their tags should be block. And this tutorial is already starting to get a little bit long, so I'm going to come back and finish this one off in the next tutorial. And what we're going to do is create some sort of collection of all the blocks in the scene. And when all the blocks are actually gone, we know that that level is actually complete. Anyways, thanks for watching. I'll see you in the next tutorial. Bye-bye.